If you could survive near a black hole, imagine this. You're near a black hole, not in some sci-fi fantasy where anything goes, but within the bounds of real physics. Let's assume the impossible. You're alive, shielded from radiation, pressure, extreme temperatures, and all the other destructive forces. All that's left for you is to feel, observe, and comprehend. You gaze at it. A black hole doesn't look like it does in the movies. There's no massive swirling vortex with fiery streaks. Unless it's actively consuming matter, it's just black. Utterly, perfectly black. A darkness so absolute that even the void around it seems brighter by comparison. It reflects nothing, emits nothing. It only warps space and time itself. You start to approach. The first thing that catches your eye is the bizarre behavior of light. The stars, once evenly scattered across the sky, now cluster into a brilliant ring around the black hole. This is gravitational lensing. Light bends as it skirts the hole, distorting and doubling. You see the same star in two places at once. The sky transforms into a surreal painting, as if crafted by an artist teetering on the edge of madness. The closer you get, the more intense the distortion becomes. But it's not just the outside world that feels strange. You start to lose your sense of time. Imagine you have a watch. It's ticking. But if someone were observing you from a safe distance, they'd see the hands of your watch slowing down. If you were falling straight into the hole, they'd never see you cross the event horizon. To them, you'd appear frozen at the edge, fading infinitely slowly. For you, though, everything would feel normal. Time flows differently for everyone, and this isn't a metaphor. It's a fact, backed by Einstein's equations and confirmed by experiments. You don't feel it directly, but there's a strange shift in your perception. It's as if everything around you is speeding up while you remain still. You're not sure how much time has passed. Minutes? Hours? Days? Everything grows hazy. Your memory functions, but you no longer trust it. Space and time here are inseparable. They bend, and with them, reality itself warps. At a certain distance from a supermassive black hole, you still don't feel physical strain. This is key. The larger the black hole, the gentler the gradient of its gravitational pull. A small black hole would tear you apart long before you reached the event horizon, a phenomenon called tidal forces, or more vividly, spaghettification. But near a massive one, you could cross the event horizon, the point of no return, without even noticing. It's strange to realize you've crossed a boundary beyond which no information can escape. Yet nothing dramatic has happened. The darkness remains, the stars are still distorted, and all you feel is a growing sense of unease. Because, there's no way back. This is where philosophy creeps in. If you can't return, does that mean it's over for you? Or do you keep living, just forever cut off from the outside universe? Scientists still debate what happens inside. Some theories suggest you simply move toward the center, the singularity, where density becomes infinite and the laws of physics break down. Others propose that inside might lie a tunnel to another part of the universe, or even another universe entirely. These are just hypotheses, none proven. But you're here, you're falling inward. Gradually, you start to sense space compressing, not in a tangible way, not something you feel with your skin, but as if distances are shrinking. It's as though the entire cosmos is collapsing into a single point, and you're at that point. Some physicists speculate that inside the event horizon, the direction of time swaps with the direction of space. You can no longer stop or turn back. Falling toward the center becomes as inevitable as moving forward in time is for us. You keep moving, even if you wanted to stay still. You're not dying, you're alive, but you're trapped in the very fabric of the universe, and you know it. That's perhaps the most terrifying feeling imaginable. Not death, but the impossibility of escape, an absolute hopelessness encoded not in emotions, but in mathematics. Inside the event horizon, when time becomes space. You're inside the event horizon. This is no longer a metaphor. To the outside world, you've vanished. Even the light that might have reflected off your spacesuit can't escape this realm. Yet, you're still here. Your consciousness is intact. Your mind is functioning. Astonishingly, you're still alive. The first thing you notice is the absence of change. The world around you seems to freeze. There's no sensation of falling, no sense of moving forward. Space and time have tangled like the branches of a tree grown in a vacuum. You can't tell what's forward or what's yesterday. Everything feels simultaneous, viscous. It's unlike any drug, any meditative state. This isn't altered consciousness, it's altered reality. Theoretically, this is the moment when something we don't fully understand happens. Time and space swap roles. Normally, you move through space, while time is an arrow pointing forward. But here, in this warped geometry, moving toward the black hole center becomes as inevitable as the passage of time. Whether you want it or not, you must move inward. There's no space to step sideways. Everything collapses into a single path. Some scientists describe it like this. You don't fall toward the center, you experience it like a day you can't skip, an event that must happen like death. The center isn't the end of a distance, it's the end of time. You can't avoid it. You can't pause it. It simply will be. You're afraid, but not because of pain or danger. There's no pain. There's only the feeling of being inside something irreversible, like being on a train that can't be stopped. Even if the tracks vanish, the motion continues. This isn't an emotion, it's physics. But now imagine a different scenario. What if the inside of a black hole isn't the end? Some theorists suggest that instead of a singularity, there could be something else, a region with stable geometry. Modern physics doesn't know what lies at the center of a black hole. A singularity is a gap in the theory, not proof it exists. For instance, there could be a passage, a hypothetical wormhole leading to another part of the universe, or even to another universe. Yes, these are speculations, but not baseless ones. Einstein's equations allow for such solutions. The catch is that any slight disturbance makes these tunnels unstable. Everything would need to be perfectly symmetrical for you to survive the crossing. And if there's no tunnel, if the center is a point where gravity becomes infinite and you're compressed infinitely, in truth, no one knows what infinity means in physics. It might just be a signal. Here, our models stop working, like a sign saying, no road ahead. At that point, it's not your bones that break. It's the entire framework of physical reality. Let's take one more theoretical leap. What if consciousness could survive this transition? Not your body, not biology, but awareness itself. Some physicists toy with the idea that under certain conditions, information isn't lost but rewritten onto a different structure. Perhaps inside, you become something entirely different, not human, not even a living being. A pattern etched into the fabric of space-time. These are conjectures, of course, but one thing is certain. Your journey to the center is a one-way trip. Even with a perfect engine, even if you screamed for help, no signal could escape. You're locked in a gravitational cage. Everything that happens to you stays inside forever. And here's what's truly mesmerizing. While the outside world keeps living for you, minutes may have passed, but for those left behind, centuries could have elapsed. You're a traveler not just in space, but in time. Even if you can't share what you've seen, your disappearance becomes part of the cosmic story. If time flowed backward, now let's imagine an even stranger scenario. What if we're not just falling into a black hole, but somehow emerge on the other side? This idea isn't pure science fiction. It's a hypothesis within the framework of general relativity. Perhaps at the center of a black hole, there's no dead end, but a passage. Not death, but transformation. In science, there's a concept called a white hole. It's a theoretical object that does the opposite of a black hole. Instead of pulling everything inward, it spews matter and energy outward. If a black hole is an entrance, a white hole is an exit. The problem is, no one has ever observed a white hole. They're mathematically possible, but their existence remains speculative. Still, in some models, black holes and white holes could be connected through a bridge, a wormhole, a hypothetical tunnel in space-time. You fall into a black hole in one part of the universe and emerge in another, or in another time, or even in a different universe. If this were true, crossing the event horizon wouldn't be the end, but the start of something new. You'd enter a realm where past and future lose their usual meaning. What would the world beyond a white hole look like? Maybe the laws of physics are slightly different there. Maybe there's no matter, only energy. Or perhaps it's the same as our universe, just inaccessible in its entirety. Your body might be destroyed, but your information could persist. Perhaps you'd become part of a new cosmos. Theories are beautiful, but what would you feel in that moment? It's hard to imagine moving through a tunnel of space, feeling no familiar gravity, seeing no landmarks. It might resemble the tunnel effect described by people during near-death experiences, or an endless, strange dream without time, but with awareness. There are even hypotheses that black holes are seeds for new universes, like a bubble splitting off from the cosmic ocean. Maybe every black hole in our universe is a gateway to another, and by falling into one, you'd become the first observer of a new world, if only for a moment. But let's step back from wild theory to reality. Imagine you're hovering near the event horizon on a stable orbit just beyond the point of no return, where you can still hold your position. What would you see? It would be a spectacle unlike anything else. Light from the stars bends so sharply that the sky curls into a circle. You'd see not only what's in front of you, but also behind you. Light wraps around the black hole, making you a witness to the strangest cosmic panorama imaginable. The flow of time for you and a distant observer would differ so drastically that hours for you could be years in the outside world. This isn't just theory, it's been confirmed. In 2019, Scientists observed time distortions near the supermassive black hole in the M87 galaxy. Not science fiction, fact. You might start to notice the stars speeding up, their birth, evolution, and death unfolding faster, as if someone hit fast forward. You'd be watching entire epochs through a telescope. You're a time traveler without ever leaving your spot. And here's what's remarkable. You're living next to the most destructive object in the universe, yet you don't die. You're staring at annihilation, and you feel more alive than ever. Because in moments like these, clarity dawns. You're part of a universe capable of understanding itself, and perhaps capable of transcending its own limits. What if you could live inside a black hole? Let's imagine the impossible, not just surviving a fall into a black hole, but existing within it. Not as a human in a spacesuit, but as a form of life adapted to the most extreme conditions. As wild as it sounds, theory allows for it. If there are stable regions of space inside a black hole, structures could exist there. This doesn't mean trees, animals, or cities. It could be life we wouldn't recognize even under a microscope. Life built not on molecules, but on fluctuations in the gravitational field, on the curvature of time itself. Scientists are already exploring concepts like timeless life. Imagine beings whose perception isn't tied to a sequence of events, but to the configuration of the entire universe at once. Picture an intelligence that doesn't think in terms of before and after, but knows everything simultaneously. For them, past and future are just different facets of a single object, like the sides of a cube. Now let's add another layer: information. One of the biggest questions in physics is, what happens to the information that enters a black hole? If it's destroyed, that contradicts the laws of quantum mechanics. But if it's preserved, where does it go? Some theories suggest that all information ever swallowed by a black hole isn't lost, but stored on the event horizon's boundary, like a film enveloping the whole. This is called the holographic principle. Essentially, all three-dimensional information could be encoded on a two-dimensional surface. If true, then perhaps inside a black hole, all matter, energy, and even consciousness don't vanish, but exist as a kind of gravitational memory. It's almost like digital preservation, but on a cosmic scale. Now imagine that life inside the hole isn't organisms, but interactions of these memories, like intricate patterns in water. Perhaps a form of thought emerges from the structures of space-time itself. This is a hypothesis, of course, but it stems not from fantasy, but from efforts to reconcile theories of gravity and quantum physics. Let's return to the human perspective. What if we found a way not only to survive falling into a black hole, but to send a robot, a drone, an observer inside? What would that journey look like? First, you'd see reality's boundaries blur, colors fade, space warp so much that objects might appear stretched and straight lines might loop back on themselves. You could look forward and see the back of your own head. This isn't a mirror trick, it's topology, where space folds in on itself. Second, you'd lose all sense of direction. Up and down become meaningless. You might move forward only to end up where you started. Your path isn't a straight line, but a curve that intersects itself like a loop. Third, you might experience absolute isolation. Not loneliness, but the absence of an external world, as if the entire universe is just you and nothing else exists. A point where consciousness confronts an absolute horizon. But now imagine, what if there's another world inside the black hole? We've talked about tunnels and exits, but what if it's a closed system, like a sphere where everything spins, reflects, and interacts? Could local laws of physics emerge in such a world, allowing stability? Hypothetically, yes. Some models suggest that under certain conditions, structures resembling atoms but fundamentally different could form inside a black hole, not made of protons and electrons, but of energy clumps held together by the curvature of space. It's as if, in a gravitational cauldron, the possibility of life is slowly brewed. Of course, this is beyond current observations, but this is where science starts to resemble philosophy. Not because it loses precision, but because it ventures where data is scarce and logic and mathematics take over. Sometimes that's enough to make astonishing predictions. If a camera were filming from a distant orbit, suppose you're heading toward a black hole, and somewhere far away on a distant orbit, a drone, a camera, or a space telescope is filming you. What would the lens capture as it tracks your journey? The first thing it would show is time slowing down. As you approach the event horizon, you appear to move more slowly. Not in your own perception. Inside your ship, your pulse, breathing, and thoughts feel normal. But to the camera outside, you're gradually freezing. The final seconds before you cross the horizon could stretch into eternity. You'd grow dimmer. The light you emit stretches, red shifting into the infrared, then the radio spectrum. This is gravitational redshift. You literally fade from the visible spectrum. From a certain perspective, you never cross the event horizon. The camera would see you forever, frozen, stuck to the black hole's edge. It's a paradox of perception. For you, the journey is over. You're already inside. But to the outside world, you're still out there, suspended in infinity. Now imagine you're looking back at the drone filming you. What do you see? Everything else in the universe speeds up. Stars in the background race by as if in fast forward. They're born, explode, and vanish. You might witness galaxies colliding, the cosmos reshaping over billions of years. This is the effect of time dilation. An hour for you could be a millennium in the outside world. This is time travel to the future without a time machine. You're simply in a strong gravitational field where time flows slower for you. This isn't theoretical. It's proven. Even on the International Space Station, time moves slightly faster than on Earth. Near a black hole, the difference becomes staggering. Now picture a more surreal scenario. You're on a safe orbit just outside the event horizon, close but not past the point of no return. What do you see when you look toward the black hole? You'd see everything. Light from objects behind you curves around the black hole and reaches your eyes again, creating a gravitational lens effect. Space seems to fold. The sky becomes a dome, and at its edge, you see distorted images of stars, galaxies, and even yourself. You could see the back of your own head. Light from you loops around the hole and returns. This isn't a joke. Scientists model these phenomena, and images captured in 2019 by the Event Horizon Telescope are just the start of understanding these distortions. Now imagine holding a mirror. It should reflect your face, right? But near the event horizon, light behaves differently. You might see not yourself, but the sky behind you, or even light that should have vanished. This isn't magic. It's physics pushed to its limits. The closer you get to the horizon, the more your gaze turns inward. You lose the ability to look far away. All you see is the hole. It consumes your horizons, leaving only one direction, down. Another intriguing detail. For an outside observer, any signal you send arrives less frequently. The first signal comes after a second, the next after a minute, the third after an hour. You don't vanish instantly, but fade like a grain of sand dissolving into eternity. This raises a profound philosophical question. What does it mean to be alive if no one can confirm whether you've died? You're inside the black hole. The camera sees you. Your signal still transmits, but you're unreachable. You exist in a realm beyond contact. Black holes thus become more than cosmic objects. They're boundaries of existence. They challenge our concepts of time, space, observation, death, and information. And remarkably, they don't break physics. They reveal how strange it can be. Supermassive black holes, slow killers. When we think of a black hole, we often picture a tiny point greedily devouring everything around it. But those are just the small fry compared to the true monsters of the universe. Supermassive black holes lurking at the cores of galaxies. These beasts have masses ranging from millions to tens of billions of times that of the Sun. Their event horizons can span distances larger than Earth's orbit around the Sun. Here's the paradox. The bigger the black hole, the weaker its tidal forces at the event horizon. Why? It's all about how gravity is distributed. A small black hole has a steep gravitational gradient. Your feet and head experience wildly different forces, tearing you apart. But a supermassive black hole's gradient is so gentle that you could cross its event horizon without feeling a thing. Sure, you still couldn't escape, but the fall wouldn't be catastrophic, just a quiet vanishing. It's as if you've crossed an invisible line. Even your ship's sensors might not register the moment of transition. Space-time there is smooth, with no abrupt jolts. Now, imagine a hypothetical ship approaching a supermassive black hole. Its crew is trained, the vessel shielded. It settles into a safe orbit far enough to linger for years, observing the cosmic giant. And you know what? It's one of the calmest places in the universe. No storms, no meteors, just the faint glow of the galaxy's background radiation. The darkest point ahead is the gateway to the abyss, barely noticeable except for its absolute blackness. But things get more interesting if the ship ventures closer. Light starts to bend. A glowing ring appears around the horizon, like the one seen in the famous M87 star image. This isn't the whole surface. It's light that nearly fell in but was deflected by gravity and sent outward. It can circle the hole multiple times, creating ghost images of the same object. You might see not just the galaxy but its reflection, flipped, compressed, distorted beyond recognition. This isn't a camera trick. It's the geometry of space. Now let's push the imagination further, staying grounded in theory. Suppose your ship dares to cross the event horizon of a supermassive black hole. What do you feel? Nothing out of the ordinary. Everything proceeds as planned. Space is slightly warped, but no more than near a neutron star. Gravity is stable, instruments are operational, you can live, you can observe. Then, a minute later, it hits you. You're inside. There's no way back. Yet the world around you still resembles the outside. You still see the galaxy, though heavily distorted. You still catch light, while it can still reach you. It's a strange sensation, being alive in a place from which there's no return. If you're far enough from the center, you might even explore inside, like navigating a tunnel. But you can't stop. You're drifting, slowly, inexorably, toward the singularity. If it's truly a point, it will eventually tear you apart. But if the singularity is something else, perhaps you'll reach something. Some theoretical models propose that inside a supermassive black hole, there could be a region where space stabilizes, known as the inner Reissner-Nordstrom region, or even a loop to another space. These are solutions to Einstein's equations under specific conditions. Pure theory for now, but not a fairy tale.